Hey everybody, this is John. I wanted to produce this video to show you how we're going to use Excel to solve the transportation method of linear programming. And the first file we're going to put up kind of explains the 5 steps we need to go through in Excel before we can run the solver function in Excel. So these are the 5 steps, and it might be a little more helpful if I also show you what we're going to build in Excel. But basically, we're going to, in step 1, enter the data that's given to us in the problem. Step 2, we're going to kind of duplicate that information, create an area where we can test out different combinations of inputs. We're going to calculate in step 3 totals for the supply and destinations, just sum up to make sure that they fit within our constraints given in the problem definition in step 1. Step 4, we're going to create a third area in Excel in which we calculate the transportation costs from and to each location. And then in step 5, we're going to create one cell that's got a formula that calculates our grand total of all our transportation expenses. So again, let me show you what this will look like in general in Excel. So we've got 3 separate areas here, and the first area is just going to be the data from our problem. And you can see over here, the boxes explain it for step 1, you're just going to enter the from and the to. So for example, in this problem, to ship from Indianapolis to Columbus, it costs $25. And the total factory supply available from New York is 14. And the total requirements for Columbus is 10. So this is just the data we're given in the problem. We're going to do in step 1 is create the second area where we allow us or Excel to kind of guess here in these cells how much we're going to ship from Indianapolis to Columbus or from Phoenix to Denver. All these cells right here, there's a total of 16 of them that we're going to have various data of number of items shipped from this location to this location. And we're going to, in step 3, create formulas that total that up because we want to make sure that, for example, the total for Phoenix here is not more than our constraint here, which is 6. Similarly, we're going to total up the columns to make sure that, for example, our total from Denver meets the requirements of 15 that we have in our constraints. And then the third area we're going to set up in step 4 and 5 is this area here where we're going to calculate how much shipping costs from Indianapolis to Columbus and from Phoenix to Denver, basically all 16 of these cells here. And then we're going to create a cell here that just adds up all of our shipping costs to come up with a total. So this is just kind of the high level. So let's actually do it in Excel. So what I have uploaded for you to take a look at and download is a file called example 15.1 initial. And so basically I just entered the data the way the problem was described, that we've got 4 factories, Indianapolis, Phoenix, New York, and Atlanta. We've got 4 warehouses that we want to ship to. We've got the shipping costs. So again, Indianapolis to Columbus, $25. New York to Denver is $80. And you can kind of see it makes geographic sense, right? It's a lot cheaper to ship from New York to Columbus than New York all the way across the coast to Los Angeles. We've got our constraints here in column F. The Indianapolis factory can make 15 units, Phoenix 6, and so on. And then we've got our requirements: Columbus 10, St. Louis 12, Denver 15, so on. So this is basically step one in that 5-step process of getting Excel ready to run Excel, where I've just set up the data as stated in the problem. So step 2, what I want to do is copy these cells. So this is, if you're doing it along, I've got columns A through F, rows 1 through 6. I want to highlight those and Control C for copy, and then go down to cell A8 and paste. And now I've just got an exact copy. But this is really not what I want. This is the broad outline of what I've got, but I want to be able to change the data here. So what I'm going to do is select the 16 cells here, my from and my to, and select all of them and hit delete so they're blank. And then what I want to do is change the heading here. I'm no longer calling that from to. I want to call that candidate solution, because this is where I'm going to enter my test data to try to figure out if it's a good solution or not. Here under requirement, I'm going to change this cell from being labeled requirements to be total supplied. And what I want to do is this row is going to be the total amount that is being sent to Columbus, St. Louis, Denver, and so on. And then here, change this label. Instead of factory supply, I want to call that total shipped. Because again, this column is going to be the total amount shipped from Indianapolis, Phoenix, New York, and so on. And what I want to do with these cells in column F is not just have the constraint entered like it was up here. What I want to do is total up these cells to the left of it. So let me go ahead and do that for the first one and show you. So out of Indianapolis, what I want in this cell is the total amount we're proposing in our candidate solution will be shipped from Indianapolis to all 4 of our warehouse destinations. So I want to type equals SUM, parentheses, and then I left click and drag over to get B9 colon E9, and that sums up everything that's being shipped out of Indianapolis. And of course those cells are blank, I just deleted them, so this number should be 0, which is good. Now I'm going to drag this formula down so that I've got the total calculated for all 4 of my factories. You can see for Atlanta, I'm summing up what we're proposing to ship from Atlanta to the 4 locations. Continuing on with step 2 here, I also want to sum up how much each of our destination warehouse is going to receive in our candidate solution. So again, I'm going to type over, get rid of the numbers that I copied from above and type equals SUM, and then choose the cells directly above. So that's equals sum parentheses B9 colon B12. You could use the auto sum, would be a little faster there, but I did it the slow way, and then I'm going to copy this over. And so again, I've got all zeros here because I'm not shipping anything. So what I've done here with steps 2, I built this kind of area, changed the headings. Step 3, I added the total calculations. So now I've got an area set up where I could make some guesses. I could say maybe Indianapolis to Columbus will be 2 units, and Indianapolis to St. Louis will be 3 units, and Phoenix to Denver will be 4 units, and New York to LA will be 2 units. I don't know. We could enter different guesses here, right? And then we could compare and say, well, gee, we want to make sure that the number leaving Indianapolis is less than or equal to 15. and the number leaving Phoenix is less than or equal to 6, and so on. And then we could see, gee, is our demand being met? Columbus, we're shipping 2 units to, but boy, they want 10, so we're low there. And again, we could try, typing in different combinations. Maybe we could say, oh, Phoenix to St. Louis, we're going to meet St. Louis demand by entering 9 units, and well, we've got 12, so St. Louis is having their demand met. But look at this, we're out of Phoenix, we're shipping 13 units, but the constraint here is that Phoenix can only ship 6 units. So this would not be a valid solution to our problem. So again, this is the way I think of it is this is where if you wanted to do this a really slow way, you could enter different numbers in all 16 of these cells, make sure they fit the constraints, and find all the viable solutions. But that would take you a very long time. So we're going to have Excel do that with the solver function, but we needed to build this area first. So let me go ahead and I selected all 16 cells here, and then I hit the delete key to wipe them out. But this completes steps 2 and 3 of my process, where I've set up this area where we can enter some candidate solution data in. So we'll continue on in the next video.